Hello students, welcome to my lecture. In this lecture I will discuss a question from the current electricity topic. So it is a symmetrical network, then we need to identify the equivalent resistance. See the circuit as follows, and they are asking find the equivalent resistance between the points A and B. So these are the 2 points A and B here. So that means the current I enters here, then the same current I leaves here. If you observe this point, so we generally have the exactly symmetric network. So the above part and below part are exactly symmetric with respect to each other. So that means if I talk about this is X point, and I can say this is also the X point. If I talk about this is some Y point, and this is also the Y point. So that means potential at X is same. They are at the same potential. Potential at Y is same. They are at the same potential. So with that, what can I redraw this network will be? So these are the things. This is the R will be remain same. This is the joint point, and this is the R will be remain same. This is the point B, and this is the point A. Here the resistance is R, and here the resistance will be R, and here will be the joint. Now I have the 2 points here, X and Y. So this is my X point, this is my Y point. This is my center point. Okay, so this is my X and Y. In between X and Y there is another resistor will be here. In between that center point and X, there are 2 resistors, this side and this side. The center point and Y, again there are 2 resistors. Then A point and X point, again there are 2 resistors. So B point and Y point, there are 2 resistors. So this is the how resistors are connected. So now you can count how many resistors will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can check it whether the same resistors will be there or not there. So 12 resistors will be there or not there. 1, 2, 3, 4, 5, 12 resistors will be there. Now the things are easy. So each and every resistors will have the same value. So you can write all are in parallel. Their values are comes out to be R by 2 and R by 2. So when I draw here, this is R only. This is also R. This is the B point and this is the A point. This is the resistance R and this is the resistance R. So this value comes out to be R by 2, and this value also comes out to be R by 2. This value also comes out to be R by 2, and here this value also comes out to be R by 2, and from here to here, and this value also comes out to be R by 2, and here this value also comes out to be R by 2. Now the current enters here, now the current will be leaving here. So that means if you see here the input consists R and R by 2, then even output also R and R by 2 it consists. So that means electrically there is no contact here. At the C point there is no contact. So that means I can redraw that will be as something like this. This is R, then C is no connections will be present, and this is R and this is R here. Then what will be there? This R by 2 and this R by 2 will be. This is R by 2, and of course this is R by 2, and of course finally here it is R by 2, and this is the R by 2 and another R by 2, R by 2, and this is another R by 2. So R by 2 will be R. Okay, now these are the 2 points for me. this is my B point and this is my A point. So R and R will be in series. The answer comes out to be 2R there. Then this R by 2 and this R by 2 will be the R. R and R by 2 will be in parallel. Then this entire network will be in series. So that means I can redraw that. When I redraw, the network will be as follows. This entire thing will be of 2R and this is R by 2 and of course this is also R by 2 and this comes out to be R by 2 and here it will be R. This R and R by 2 will be in parallel. The answer comes out to be R into R by 2 divided by R plus R by 2. So answer comes out to be R by 2 plus 3 by 2, that is R by 3. So that R by 3 is in series with that R by 2 plus R by 2. Then the answer comes out to be R by 3 plus R, that is 4R by 3. Then finally it comes out to be here 2R and this entire thing comes out to be 4R by 3. So R by 3 and 4R by 3. So I can write here A here and that to be B here. Then equivalent resistance between A and B will be 2R into 4R by 3 divided by 2R plus 4R by 3. So when it comes out to be 8R by 3 divided by 10R by 3. And of course here R square comes. Then RAB will be is equal to 8R by 10. 2 4 ja, 2 5 ja. Answer is coming out to be 4R by 5. Okay. So this is generally this type of problems we call as symmetric problems. You need to identify that there is this is the input part of the problem we call and this is the output part of the problem. So with respect to input, output is symmetric. With respect to output, input is symmetric. And along this line also there is a symmetry exists. So that means upper part is exactly same as that of the bottom part. That means this point potential and this point potential will be same with respect to this point A. Similarly, with respect to point A or with respect to point B, this point and this points will be at the same potential. So based on that we can do here. The same again, the same comment I did here also. Okay, so when we can think of here something like this. So it is something like this. When the current I comes here, assume that it breaks up into two parts, X here and Y here. The same thing I expect here, X is here and Y is here. So that's why here it appears that there is a connection, but logically there is no connection here. So there is no electrical connection. That's why the part came down here. There is no connection. So whatever the Y current comes here, then again the Y current divides into two parts, something like Y1 and Y2. It will combine again as a Y. This Y again combines with the X will become I. Okay, I hope it is clear. So thank you for watching my video. Please subscribe my channel. Don't forget like and share.